How can cooling systems dissipate heat effectively for specific loads? Imagine trying to keep a hot cup of coffee from spilling while walking across a bumpy road. That's similar to how cooling systems work to manage heat from different machines or devices. When a load generates heat, the goal is to transfer that heat away quickly and efficiently. The main methods involve conduction, convection, and sometimes radiation, all tailored to the specific heat source and environment. Starting with conduction, heat moves directly through materials. Using materials like copper or aluminum for heat sinks helps because they conduct heat well. Increasing the surface area of these heat sinks with fins or pin arrays makes a big difference. The more surface area exposed to the cooling medium, the faster heat can escape. Think of it like spreading out a hot object to cool faster. Convection is another key player. It involves moving fluids like air or liquid around the heat source. Natural convection relies on warm fluid rising and cooler fluid sinking, but forced convection uses fans or pumps to speed things up. For example, a fan blowing air over a heat sink boosts the heat transfer rate. Liquid cooling systems circulate coolant through pipes, which can absorb and carry away more heat than air alone. Thermal interface materials are also important. These are special pastes or pads placed between the heat source and the heat sink. They fill tiny gaps that would otherwise trap air, which is a poor conductor of heat. Using these materials reduces thermal resistance and helps transfer heat more smoothly from the load to the cooling system. Material choice plays a big role too. Copper and aluminum are popular because they conduct heat quickly. Copper is more expensive but offers better thermal conductivity, while aluminum is lighter and cheaper. The right choice depends on the specific application and budget. Ambient conditions matter as well. Cooler surroundings increase the temperature difference between the load and the environment, making heat transfer easier. Designing enclosures that promote airflow and prevent heat buildup is essential for maintaining safe operating temperatures. Every load has a thermal limit, a maximum temperature it can handle without performance issues or damage. Cooling systems must be designed to match or surpass the heat generation rate. This involves calculating the heat load, understanding the heat transfer coefficient, and sizing the surface area of the cooling components accordingly. For very high or specialized heat loads, advanced techniques like phase change cooling are used. Thermoelectric coolers, which use semiconductor modules, can absorb heat on one side and releases it on the other, providing precise temperature control. Refrigeration systems can also be employed when extreme cooling is needed. In practical terms, electronic devices often use heat sinks with fans to keep processors cool. Industrial machines might use liquid cooling systems where coolant circulates around critical parts. High-performance equipment may even use thermoelectric coolers or refrigeration units to maintain strict temperature conditions. So, effective heat dissipation hinges on designing cooling systems that maximize heat transfer through larger surface areas, increased convection, smart material choices, and proper environmental management. When traditional methods aren't enough, advanced cooling techniques step in to handle the extra heat.